All right, so in this lesson, we're going to be dealing with what we call arithmetic and geometric sequences. So we're going to be able to do this successfully. You need to be able to extend and apply a pattern, identify a sequence as either arithmetic or geometric, identify the common difference or ratio, and then write the recursive and or the explicit definitions of an arithmetic or geometric sequence, and then use it to find specific terms. So by the end of class, the subjective mastery will look like one of these, or answering these 4 questions. So given a sequence, identifying if it's arithmetic or geometric, writing the recursive formula, writing the explicit formula, and then using that formula to find a specific term. It's also going to involve finding the pattern and filling in for missing numbers. All right, so the first thing I'd like you to do is I'd like you to just analyze these 5 different sets of numbers, these sequences, and see if you can identify the missing terms. All right, so for A, hopefully you were able to identify that 10 is the missing term. A sequence is going to follow the same pattern every time, so I notice that I'm adding 3 here, and I'm adding 3 here, so that means I have to add 3 here. All right, for B, hopefully you saw that 11 and 15 fit in there. I looked at here, I'm adding 4. So as I move to the right, I add 4. So to find previous terms, I would subtract 4. So 19 minus 4 is 15. 15 minus 4 is 11. And then 11 minus 4 is 7. So it's following that pattern. As I move this way, I'm adding 4 each time. All right, so for C, hopefully you're able to see it's 14, 20, and 26. So when I think about this one, to go from 8 to 32, I'm adding something 1, 2, 3, 4 times. So I have to add the same number 4 times to get from 8 to 32. So if I do 32 minus 8, that's going to tell me the difference. So 32 minus 8 is 24, and I'm doing it 1, 2, 3, 4 times. So by dividing by 4, that tells me that every time I'm going to add 6 in order to keep that same timing, or that same spacing. So 8 plus 6, 14 plus 6, 20 plus 6, 26 plus 6, and it checks. All right, so for D, I'm adding 7 each time, so I end up with 18, 25, and 32. And then for E, I see that from 33 to 39 would be adding 6. So if I want to move backwards, I'm going to subtract 6, and then subtract 6, and subtract 6 to check and make sure it works out. All right, so for example 2, I'd like you to see if you can fill out any of these missing numbers. Now, I want to note that on these, they're all being multiplied or divided by something. So the sequence is no longer adding or subtracting a constant. I want to see if you can determine what could be multiplied or divided in order to fill in the missing pieces. So in A, I noticed I saw some fractions over here and I wasn't really sure what to do. So I looked for the continuation of the pattern, and I see that each time I'm multiplying by 2. So in order to work backwards, I'm going to divide by 2. So 2 divided by 2 gives me 1. 1 divided by 2 is a half, and half divided by 2 is a fourth. So I can see that it's being multiplied by 2, but to get that, I divided to work backwards. So for B, I saw that I had some really big numbers, and I can see that they're getting bigger, so I'm going to multiply it as I move to the right. But to figure out what I would multiply by, I'm going to take this number, and I'm going to divide it by this number, and it will tell me the factor. So what is being multiplied by 63 to get 189, and I see that I am multiplying by 3. So as I move right, if I'm multiplying by 3 to find previous, I'm going to divide by 3. So 63 divided by 3 is 21. 21 divided by 3 is 7. All right, so for C, I see that the numbers are getting smaller. And so I noticed that to go from 1 to 0.5, I would divide by 2. So as I move to the right, I'm dividing by 2. So as I move to the left, I need to be multiplying by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So for D, I noticed that every other one is negative. So in order to multiply a negative number by something and get a positive, this number has to be negative. So whatever my factor is, whatever I'm multiplying by, has got to be a negative number each time, because a negative times a negative is a positive, and then a positive times a negative is a negative. Then a negative times a negative is a positive, and so on and so forth. So to get from negative 4 to 12, I would multiply by negative 3. 12 times negative 3 is negative 36. Negative 36 times negative 3 is 108, and 108 times negative 3 is negative 324. So every time I'm multiplying by a negative 3. All right, and lastly for E, I noticed to get from 3 to 6, I would multiply by 2. So to work backwards, I've got to divide by 2. And so 3 divided by 2 is either 3 over 2 or 1.5. Either answer will work. Okay, so what I'd like you to do is I'd like you to look at these patterns, either adding, subtracting, or multiplying and dividing, and see if you can determine the first number in each of the sequences. All right, so in the first two, hopefully you noticed that I was adding the same number each time. And so to find that previous number, I simply subtract. And then in the last three, I'm multiplying or dividing as I move forward. So I simply have to do the opposite to find the previous number. And so I end up with 2, 5, and 48 for C, D, and E. All right, so we have done the first part of our sub-objective to extend a pattern. Go ahead and have an interaction in your notes. What's something that's part of the new learning? What are you going to need to remember? What makes sense to you? What is confusing? What questions do you have? All right, so we are going to learn about arithmetic and geometric sequences. So the biggest thing with arithmetic sequences is they are linear. So they're adding or subtracting the same number every time, that constant rate of change. This is what we call the explicit formula. The explicit formula is a little bit different. We're going to see the recursive formula in the next slide. But this is the general formula. You will actually be given this on the TN Ready exam on your formula sheet. So A sub n, and that's what that sub means, A sub n equals A sub 1 plus D times the quantity of n minus 1. You may also see it as this where the D is out back. It doesn't matter. I'm still distributing. So the n is the nth term. A sub n is the output. So given whatever position that term is, so the first term, the second term, the third term, which is my input, it will tell me the value of that term. So to get that, we use A sub 1, which represents the first term because the n is 1, and D is that common difference. So if I'm adding a number, it's going to be plus 4 if I'm adding 4 each time, or minus 8 if I'm subtracting 8 each time. So this is the explicit formula of the arithmetic sequence, which arithmetic is linear. All right, this is the recursive formula. So it's the exact same information, it's just going to be written literally like this. The only numbers that you're going to fill in on the recursive is you're going to identify the first term, and so you'll put it here. So if the first term is 4, I would put a 4 here, and then I'm putting in the plus D on the end. All right, so geometric sequences are also known as exponential sequences, meaning they have a common ratio. So I'm either multiplying or dividing by the same number each time. So again, you're going to be given this formula on your formula sheet for TN Ready. It's the exact same lettering except for the R is now a D, and it's the way that I put it together. I'm sorry, the D is now an R, and it's the way I put it together. So A sub n is still my output, given the nth term. A sub 1 is still my first term. R represents my common ratio. So if I'm multiplying by a number, that goes there. Now if I'm dividing, another way to divide is to do the fraction. So dividing by 2 each time, my R is going to be 1/2. And then it's to the power of n minus 1. And n is my term number or my input. And this is my recursive formula, so it's the same concept. I'm going to identify a sub 1, so I'm going to give the first number in the formula, and then I'm going to put in the rate of change. So, I'm sorry, not the rate of change, the constant, the ratio. So all of this that's in black, except for this and this, will be the exact same every time. All right, so when I am using the formulas, I need to know which one to use, and then I need to know how to put the numbers in appropriately. So the first question I'm going to ask myself is, what is the pattern? So first of all, am I adding or subtracting, or am I multiplying or dividing? So I need to identify, is it arithmetic or geometric? So then once I've decided which operation is happening, I'm going to use the formula. And then I need to know the first term, what's the common difference if it's linear, or common ratio if it's exponential, and then how do my values fit into the formula, and if it's arithmetic, how can I simplify the formula? So we're going to go through some examples. All right, so the first question is, what is the pattern? Am I adding, subtracting, or multiplying, dividing? So I see I'm going from 7 to 10 to 13 to 16, and I see that each time I'm adding 3. So the pattern is adding, subtracting, so the formula I'm going to use is arithmetic. So we are going to write both formulas for arithmetic. So we're going to do the recursive and we're going to do the explicit. So first of all, what is the first term? So 7 is my a sub 1. It's my first term. My common difference is 3. I'm adding 3. And so how do my values fit into the formula? All right, so my recursive formula is going to be a sub 1 equals a number, and then a sub n equals a sub n minus 1 plus r. And what recursive means is I use the previous number to find the new number. My explicit is going to be this. So I'm simply going to take these two formulas, and over here for my recursive, I'm going to list what the first term is, and I'm going to say what the common ratio is. Those are the only things that I need to add in. So the first term is 7, and my common ratio is plus 3. So this right here is my recursive formula. Now over in the explicit, I'm going to have to replace my a sub 1 and my d. So I'm replacing a sub 1 and I'm replacing d. So again, a sub 1 is 7 and d is 3. So they're saying the same thing, they're just in two different forms. So I found my first term, found that, and I fit them into the formula. Now the last thing I have to do is, if it is arithmetic, which we decided since it's a constant rate, I do need to simplify. So all I'm going to do is just distribute my 3 and combine my like terms. So a sub n equals 7 plus 3n minus 3. I'm going to take 7 and minus 3 and put them together. So a sub n equals 3n plus 4. And that is my explicit formula. So I have written both of my formulas, I've simplified, and now the last thing I need to do is use your function to find the 19th term. So 19th term is the position, so that is the n value. So it's going to be easier to use my explicit. So I'm going to say a sub 19. So all that's saying is the term value when the position is 19 is going to be 3 times 19 plus 4. So a sub 19 is going to be, so I got a sub 19 is 61. So basically, if I continued this pattern out, so this is the first term, the second term, the third term, the fourth term. If I continued that out to the 19th position, the value is going to be 61. All right, so in this next example, my pattern is starting at -2, then -4, then -8, then -16. So if I wanted to, I could turn this into a table. So n is the position number, and a sub n is the value of that position number. So the first term is -2, the second term is -4, the third term is -8. The fourth term is -16, and so on and so forth. So if a table helps you see it better, that's fine. The first question, am I adding, subtracting, or multiplying, dividing? Well, I can see that each time I am multiplying by 2. So my R is going to be 2 because it's getting bigger. So which formula should I use? If I'm multiplying, dividing, then this is going to be a geometric sequence. So I'm going to write down the recursive and the explicit functions for a geometric sequence. So my recursive, again, is going to be simply, hey, here's where the pattern's starting, and then every value is going to be the previous number times the R value. So in this case, I can go ahead and replace the R. I know it is 2. And over here, in my explicit, it's just a sub 1 times whatever R is to the n minus 1. So I'm going to replace this with 2. And then what is my first term? Well, my first term is negative 2. So I can replace a sub 1 in my function with, and I'm going to put it in parentheses just to keep it together, with negative 2. And over here in my recursive, I'm going to replace this and say my first term is negative 2. So those are my two functions that I have to write. This is the recursive and this is the explicit. They mean the same thing. So I'm looking for the 16th term. So I'm looking for when n is 16. So I'm going to say a sub 16 equals negative 2 times 2 to the 16 minus 1. So a sub 16 is going to be, and I'm just going to type that into my calculator, and I get negative 65,536. So if this pattern continues all the way out to where the input is 16, so the 16th position, the output is going to be negative 65,536. All right, so what I'd like you to do is I'd like you to pause the video and see if you can write both the recursive and the explicit formula and then find the 10th term. All right, so when I wrote my recursive, well, first of all, I identified that it is going to be a common ratio every time I'm multiplying by negative 6. And my first term is 1. So once I've done that, I was able to put my recursive formula together. So a sub 1 is 1, and then a sub n equals a sub n minus 1 times my common ratio, which is negative 6. And then my explicit function was a sub n equals 1 times negative 6 to the n minus 1. And I put negative 6 in parentheses because it's that whole value being raised to n minus 1. So if I'm determining the 10th term, that's when n is 10. So I simply used my explicit function and I was able to get negative 10,077,696. So if this pattern continues out to 10, that's what it will be. All right, so example 7, go ahead and pause the video and try this one. All right, so on this one, it is getting smaller, and it's getting smaller by a common amount, a common difference, so that's going to be an arithmetic sequence. So when I put it together in both of my formulas, I end up with a sub 1 is 386, and then a sub n equals a sub n minus 21. Over here in explicit, I plug those same values in, and then I distributed to simplify because I need to make it simpler. So a sub n is simply negative 21n plus 407. So if I'm looking for the 8th term, I put 8 in for n, and I get 239. All right, so pause the video and try example 8 on your own. All right, so for example 8, you should have seen that it is a arithmetic sequence with a common difference of negative 11 and a first term of negative 5. So my two functions are here and here. And then using this function, I was able to find the 9th term by plugging 9 in, and I got a sub 9 is negative 93. So if this pattern continues out to the 9th term, the value is going to be negative 93. All right, pause the video and try number 9 on your own. All right, so in this one, hopefully you were able to determine that the common difference is negative 0.4, so it is an arithmetic sequence. So here's my recursive form of the function, and here's my explicit. And so to find the 11th term, I simply put 11 in for n, and I got negative 3.1. All right, this is our final example. Go ahead and pause the video and try this one on your own. Now, I want you to keep in mind what I said earlier about dividing is actually going to be a fraction. All right, so on this one, hopefully you saw that it's being divided by 6 each time. And we don't write divided in it, where actually everything is being in terms of multiplying, so that's why we write it as 1/6, because dividing by 6 is the same as multiplying by 1/6. So here's my recursive form of the function, and here's my explicit. And then if I'm looking for the 4th term, I put 4 in, and I ended up with 1. All right, we have identified, defined, and applied an arithmetic and geometric sequence. So we are going to wrap up this lesson. All right, so go ahead and have an interaction in your notes. What makes sense? What questions do you have? What are you going to need to remember? What are the important pieces of information? So when you're studying for your test, what are the essential things that you need to know?